Hi, let's take a look at an overview of the hip and valley calculations in ClearCalcs. In both our Woodbeam ASD and LRFD templates, we have the option to design hip and valley rafters. So if we open this up, we can see that we are designing in NDS 2018, and the assumptions are stated here. To start, we can select our member properties. We can use our member selector to choose the size and grade, and we can also input the number of plies. Next, we can define our roof geometry. By default, we have our roof with equal sides and slopes, but if you're designing a roof with unequal slopes, you can adjust the roof pitch values. If you had a specific side length that you're designing for, you can back calculate that in roof pitch too. For example, if we wanted to have a second side length of 8 feet, we would multiply out the first side length by alpha roof 1. So that would be 10 times 6, and that would give us the height. And then we would divide that by the side length that we want, which we said would be 8 feet. Now we can see that our roof pitch is calculated to be 7.5, and our side length is 8 feet. In our supports table, the position from left is at 0, which would be at the end of our rafter or the leftmost side, and the 13.7 would be indicated here. Next, we can define our loads. By default, we have a roof, snow, and wind load. If we select the orientation to be gravity, we're applying the load straight down. But if we were to select aligned, this would be loaded perpendicular to the inclined beam based on the angle as shown up here. Lastly, we can define our design conditions. These are linked with the project details page over here, and you can change the values either here or in the project details page. You can check out our Woodbeam video for more information about the intermediate calculations, or you can open up the tabs here to see more about where these factors are being applied and how they're being used in our calculations. Scrolling back up to our summary, we can determine if moment, shear, bearing, or deflection governs our design.